Hello, this is Dr. San Abdullah with the course Introduction to Natural Language Processing. And we are doing the topic Syntax and Parsing Part 2. And in this video lecture, we'll be covering parsing and the grammars. And you will see how much interesting this material is with reference to natural language processing. And the supplemental website for this course is easymcq.com/goget, which is basically a learning management system. And it has wonderful features. You can personalize your learning experience by selecting the type of question and answer you would like to go through. You can select the subject and the topics, and of course, you can personalize your viewing experience by setting the interface, tracking your progress, and performing searching. And of course, you can also do the questions and answers and MCQs to establish how much you have learned. So, these are the videos which I would suggest you take a look to maximize the benefit from this learning management system. And these are the topics which are covered in this course. And right now we are at the topic number 6, which is syntax and parsing. Right now we are at the topic number 6, which is syntax and parsing. Now let's move on to the supplemental website. So we are at the supplemental website, and as you can see, there are quite a few courses here. We have core computer science courses, and we also have cutting edge hard courses. In addition to natural language processing, we have artificial intelligence, and we also have machine learning and so on. So let's move to the course of our interest, which is natural language processing. And we move to the topic of our interest, which is syntax and parsing. Okay, so what is semantics and what are the importance of semantics? That has already been covered in part A of this topic. So we will move on to the next set of questions and answers. Question number 6, starting from. So what is syntactic parsing in natural language processing? So basically, there's two types of syntactic parsing, and we are interested in looking at the rules which are followed while parsing is done so as to benefit which at the downstream in the context of machine translation, in the context of speech generation and so on. And it also involves creating the syntactic tree. So let's go into details. So let me open this marker here. So we are parsing is a process of analyzing the structure of a sentence according to a specific grammar. So grammar is a set of rules, and those rules need to be followed, as I mentioned in the previous topic video lecture also. For example, the cat sleeps. Syntactic parsing identifies the cat as the subject and sleeps as the predicate or the verb. So there are basically two main types of syntactic parsing. We have constituency parsing and dependency parsing. We'll be covering both of them. So constituency parsing breaks sentences into nested phrases, right? And dependency parsing focuses on the relationships between the individual words. So one is breaking, the other is looking at the relationships. Okay. So this example clarifies it. Now let me clean this and we move on to the more of the material. So what is the role of syntactic parsing? Role of syntactic parsing, understanding the structure of the sentences. Understanding this is in double quotes because the machine doesn't have that level of understanding. But what we want to say is that we are able to convey it to the machine. Okay. And where does it works? It works in machine translation, and there has to be correct grammatical structure because it has to follow that structure from one language, and in the other language that structure may be entirely different. So this kind of parsing should ensure that there it is not erroneous. What are syntactic trees or parse trees is a visual representative structure of a sentence. I will show it to you, and things will become clear. For example, if we create the tree for the cat sleeps, then the cat sleeps with a simple, which is very simple. The cat is the subject and sleeps as the verb node. Of course, if I say that the cat sleeps on the mat, okay, then we have a more interesting tree, but not a very complex one. Then we have what is called as the bottom-up parsing and the top-down parsing. Top-down parsing, the process begins with the highest level, okay, and the bottom-up parsing, the process starts with the words which constitute a sentence or a paragraph. Okay, let's move ahead. So, what are the applications? Is machine translation, sentiment analysis, question answering, and so on. So, this diagram basically briefly describes what we have just discussed, and we'll discussing more of this material. So, let's look at some interesting trees. So, make a parse tree following these sentences. Give the toys to the children, and give the children the toys. So, let's look at it. So, we have these two sentences, and parse tree. What is a parse tree? Parse tree as a hierarchical structure, okay, and that represents the grammatical structure of a sentence, okay, and that helps the machine understand. And this parse tree is broken into parts starting from the sentence, which is the top, okay, and then we have the noun phrase, we have the verb phrase. So let's look at this example. Let me clear this also. Let's look at this example. Give the children the toys. So what we have is as the sentence, this is the sentence, and then give is a verb phrase, and noun phrase is the children, and so on. And we see that for the second one we have verb, okay. This was the verb phrase and the verb was give, noun phrase, and you can see that the verb phrase contains the main verb in its argument, which has the following constituents. So if you look at the trees for both of these sentences, you can see that the trees are not, of course they cannot be same, but you can see the structure is very different, okay. So give the children the toys, give the toys to the, so where the structure seems to be similar, okay, but we see that when we go to the teacher, to the children, we have this determiner, okay, and we have the nouns here also. So in this way the machine is able to understand by creating a parse tree that what is intended by that statement, okay. Okay, now this what we had was a parse tree. Now we move on something different, which is the dependency parsing diagram. For this statement, the quick fox jumped over the lazy dog. So for in this case, we have the jump, the determiner is the fox, okay, jump is the root, and everything is centered around the jump, and you can read it that what is what over here, and this is the corresponding, what is this? This is called as a dependency parsing diagram, and this is directed, and this was not directed. The parse tree was not directed. This dependency diagram is directed because it is showing the dependencies between the different words in the sentence. All right. So now let's look at what are context-free grammars and what are dependency grammars. So the context-free grammars do not work on the context of what has occurred before, which is that's why it doesn't look at the context. And the dependency grammar is the logical opposite of the context-free grammar. So let's look at context-free grammar. Why it is called context-free? Because the rules of deriving strings depend only on the non-terminal symbol, not the end one, non-terminal, not on the context in which it appears. So the context is not here, okay. So we have the set of rules for the context-free grammars. For example, we have this what we have is sentence, okay, simple sentence, and then we have the noun phrase and the verb phrase. Sentence, noun phrase, and the verb phrase. And in the for context-free grammar, so this is context-free grammar. Then we have the production rules, possible ways that non-terminal symbols can be expanded into terminal symbols. So these are the production rules. So noun phrase, determiner, and the noun itself, okay. And derivation of the parse trees is done, and of course these diagrams are representative of the relationships. I may be going a little faster here because there's not too much focus on the subsequent topics based on this topic, but this is, of course, this is important. So contextual grammars can be used to define the structure of the sentences, and the dependency grammars, in dependency grammars, okay, the focus on the relationship between the words in the sentences, in on the relationships. The cat sleeps, okay, the noun phrase the cat sleeps is the head of the verb. So this is how, and then we have the dependency relationships. You can see that these relationships are not the way the relationships were defined in the context-free grammars. In the sentence, the dog barks, the dependency tree would show dog as the subject of the verb. Barks with the no, this tree is not the actual tree. This is the abstract data type tree which we are talking about. So we have different types of dependency grammars, projective grammars, and we have non-projective grammars, and so on. And it has many applications, including parsing, machine translation, and so on. So now we move on to the last three Q&A of this topic. So we move towards the conclusion of this topic. So what is the syntactic ambiguity and its causes? So we are looking at the parsing and syntax, and syntactic ambiguity arises when a sentence or phrase can be parsed or interpreted in multiple ways. So that's where, so it is interpreted in multiple ways. For example, I have been mentioning this example a number of times. So I saw the man with a telescope. I used a telescope to see the man, or the man I saw had a telescope. So that is an ambiguity. Okay. And lexical ambiguity is when a word has multiple meanings. Over here, the words didn't have any multiple meanings, but here they have multiple meanings. So this is the standard example also. A bank could mean a financial institution, and the bank could be a river bank also. And then is the structural ambiguity. Let me clean this and we move on. Structural ambiguity is, let me get the marker. Okay. Uh, Sentence can be parsed in different ways because of the structure or the syntax used. Flying planes can be dangerous. Now, it could mean the act of flying the plane, or it could mean the flying of the planes themselves. Okay. Like, for example, low flying planes. So, which are flying are dangerous. So this is again ambiguous thing. Attachment ambiguity is the same and is very similar to which we had earlier looked at. And then we have coordination ambiguity. Coordination ambiguity, multiple ways to interpret how elements are coordinated in a sentence. John and Mary saw the movie. It could mean what? John and Mary both saw the movie together, or it could mean that John saw the movie and Mary saw a different one. John and Mary saw the movie. It's not clear, right? So that is again ambiguity. Of course, there are many ways of figuring this out. And punctuation ambiguity. This is kind of a funny, like black joke. So let's eat grandma, and if you remove the punctuation, it's a very different meaning altogether. So let's move on. And of course, if you're interested, let me clean this. So if you're interested, there are additional references. So what is the impact of syntactic ambiguity on parsing? How does it affect actually? So increased complexity in the interpretation of the sentence because there are many possibilities. There are many meanings also. Challenges in disambiguation, meaning understanding of the meaning or removing the ambiguity that becomes more challenging. Slower parsing speed because obviously the complexity of the problem has increased due to multiple meanings. Impact on accuracy and difficulties in machine translation because we see there are many meanings also. So let me go through it and then it will become very clear. So increased complexity. So we see that because of this, we have many options. We have two options. So of course, the complexity of the problem increases. And challenges in disambiguation, it becomes challenging, of course, for the bank example or for the bark example. The dog is barking and the bark on the skin of a tree. So that, of course, is there. And the slow parsing speed. Why? Because since the parser must explore multiple parse trees and evaluate each possible structure. So I've shown you those multiple parse trees also, and of course there can be different ones also for the same statement. For example, the old man, the boats. The old man, the boats. Now the old man over here means that the person who is looking after the boats. Okay, and of course the parser must parse the sentence, process the sentence, and whether man is a verb or man is a noun. So of course that increases the computational complexity. Impact on accuracy and dependency. Parser to correctly identify the relationship because of these ambiguities. Otherwise, these things will be wrong. And she saw the man with the telescope similar to the previous one, and this will impact significantly on text generation or speech generation or translation also. It will have significant effects on it because of these disambiguities. Machine translation, problem in sentiment analysis that I've already mentioned. I can't recommend this movie enough. Now this is negative sentiment or this is positive sentiment. It's not very clear. So it's a challenging problem. And so now when we have these problems of disambiguation and their impact, and we as the solution is able to take care of them or tries to take care of them. So how do you evaluate the parsing? So there are different parsing matrices, right? So we have the precision and the recall, which of course in F1 score accuracy. They are not limited to natural language processing or to parsing. They have many other application domains also. But here we have one thing which is, for example, I can share it with you. So we have recall, we have F1 score, we have attachment score, cross entropy, right? The predicted. Let me open the marker. Okay, so the predicted distribution and the actual distribution dependencies. Okay, so that is again, of course, not limited to natural language processing. Then, of course, we have other criteria also. For example, let me clear this first. Okay. So, labeled precision and recall. What is labeled precision and recall? Both the correct head and the correct label are predicted. So the prediction is made about how it should be parsed, and which is verb and which is the adjective. Okay, and if the correct label dependency between cat and sleeps is predicted, right? And of course, the parsing speed and efficiency. Efficiency evaluates the trade-off between parsing quality, accuracy, and the computational resources. So the more computational resources are thrown in terms of time and computational power, the accuracy is going to obviously increase. So these are the trade-offs. So with this, we complete this topic. Thank you very much.